So in this video, we're going to continue our work with properties of exponents, and we're actually going to introduce you to negative exponents. And in order to get to that topic, I want you to look at this table in which we have powers of 3, and I want you to see a pattern. 3 to the 5th, we know that in exponential form that represents this expanded form where we have 5 copies of the base, right? The exponent tells us how many copies of the base, and so that we have 3 times 3 times 3 times 3 times 3, which is 243. Now, to get to the next entry in this table, we can divide by 3, which is going to give us 3 to the 4th. We also notice that our exponent is going down by 1, and now we have 3 to the 4th, which is 81. And then if we take 3 to the 4th and divide it by 3 again, so we have these 4 3's and we're dividing by 3, we reduce 1, and now we have 3 cubed, which is 27. And again, our exponent has gone down by one number, right? One integer. 3 cubed divided by 3, that's going to give us 3 squared, which is 9. 3 squared divided by 3, that's equal to 3, and we have 3 to the 1st. And now again, 3 to the 1st divided by 3 gives us our 1, and our exponent, which has to go down by 1, is 3 to the 0, and this is our zero exponent property that we introduced to you in the last video. But now let's continue that pattern going, and we're going to take that 1 and divide it by 3. So again, we're going to divide 3 to the 0 by 3, which means our degree is going to go down 1, and now we have 3 to the negative 1. We're introducing 3 to the negative 1, and notice that we get 1/3. So this is important, that 3 to a negative 1 power is giving us 1/3, which is the reciprocal of 3. Of the base. Okay, I want you to keep that in mind. And this pattern continues. So if I go subtract another 1 from the exponent, now I'm at 3 to the negative 2. So now I've got 1 over 3 squared. So I have 1/3 divided by a 3 over 1, which is the same as multiplying by another 1/3. And so now I have 1/9. Now you see that this pattern, you can start to get a feel for the fact that these negative exponents are giving us these fractions. Okay, let's take a look at the rules. Here again then is our properties of negative exponents. What we learned from the pattern is that if we have x to the negative 1, that's the reciprocal of the base. You're going to learn that if we have a negative exponent, x to the negative n, that's going to be the reciprocal of x to the n. So these are reciprocal. We're going to talk about these other rules as we do the examples. But the main one that I want you to keep in mind right now is that x to a negative exponent we can rewrite as the reciprocal of x to the positive exponent. And that this x to the negative 1, that's just the reciprocal of your base. So take a look at 5 to the negative 3. And so 5 to the negative 3, we'll use the reciprocal, and you're going to write 1 over 5. But now your exponent is positive. See that? Positive. So not only did you take the reciprocal, that took care of the negative in front of the negative 3 exponent, and so when you rewrite the problem, your exponent is now positive. And so what is that? Well, 1 over 5 cubed is equal to 1 over 125. Just so you know, this is evaluated. In number 2, notice what we've got. We've got 7x in a parenthesis, that's your base, and it is being raised. So that's 7x, and it is being raised to the negative 2 power. Again, take your base and you're going to write 1 over, and then keep your base in the parentheses, but now your exponent is going to change to a positive 2. See that? So it gets changed, the sign. And then let's continue this, because now we can use our product to a power, and we know that this is the same as 1 over 7 squared x squared. So that's our power rule, right? And we know that 7 squared is 49, so this is also 1 over 49 x squared as a simplified example. So you're going to notice that in our final examples in these problems, when you start to work on them, you want your answers with positive exponents only. So you want to use the rules. So now number 2 and number 3 look different. I hope you can see that there's a difference. And we talked about in another video how when you don't have parentheses as you do in number 3, that this exponent of -2 will only be applied to what's directly in front of it. And in that case, that this is your x. Okay, so that x is raised to the -2. What's the exponent, do you think, on the 7? And if you're thinking of a +1, you're absolutely right on that. Notice that 7, its exponent is a +1. So he's taken care of in terms of having positive exponents only, right? But now we have to do something with the x to the -2. So I'm going to rewrite the 7, and then I'm going to put a times. And then we're going to rewrite the x to the -2 using the reciprocal. So it will be 1 over x squared. So notice how, again, how we use the reciprocal, but we also change the sign on the exponent to positive. Then multiply this across here, and our final answer will be 7 over x squared. So you see how different this answer is to number 2, where the 7x was in a parentheses with the -2 exponent. We get two different answers. So you want to be really mindful of checking for those parentheses. In number 4, we've got x to the -5. So we definitely have a negative exponent there that we're going to have to take care of, right? And then that's over 6. And then what's the exponent on the 6? Yep, it's a 1. So the 6 is happy, right? This is what I tell my students, that the number is happy. That means he's kind of liking where he's living. He's living down in the basement there in the denominator. He's okay. His exponent is 1 and it's positive. It's the x that needs to move. We are going to write 1 over x to the 5th. Okay, so that's this guy. Times, and then this is a 1/6, isn't it? That's 6 being there in the denominator. That's like a 1/6. Multiplying across, we'll get 1 over 6x to the 5th. And again, notice the 6 did not move positions because the 6 had an exponent of +1. So the 6 liked living in the denominator. The x had a -5, so it needed to move from the numerator down to the denominator because we needed to use reciprocals. I hope you're starting to get this. By the way, this topic right here, exponent rules, especially when they start involving integers or negative and positive numbers, this topic is challenging for students. And so a lot of practice will be really helpful. The more you can practice these problems, the better off you're going to be in your tests and homework. Okay? I promise you that based on many years of teaching this. All right, let's look at number 2. In number 2, now the -15 goes with just the x. Okay, and the 2 has a little invisible 1. So here's what we've got. I'm going to rewrite here. We have 2 to the 1st power, and then we have x to the -15. And the x to the -15 needs to move from the denominator up to the numerator. Why? Because that's the reciprocal. Okay, so the reciprocal when your negative exponent is in the denominator is to move to the numerator. So, but the 2's happy, the 2's fine. So we're going to write x to the +15 to move the x to the -15 up to the numerator, and we're going to leave the 2 in the denominator because the 2 has an exponent of 1 and does not need to change. So hang on, I'm going to show you this property here in our table. Okay, so look at it right here. This one says that when you have the negative exponent in the denominator like this, that it is going to move up because there's like an invisible 1 under there, isn't it? So it's going to move up to the numerator and change signs. That's what we did. So look at number 6. Number 6 has numbers instead of x's. Do we treat them differently because they're numbers, the bases, instead of x's? The answer is no. This 4 to the -4 needs to move, but the 4 squared, he's okay. So we're going to, this one's going to move down to join with the 4 squared. Now that means that I'm going to have nothing left in the numerator, right? So then you want to make sure you put a 1 there. So the 4 squared is happy. He likes where he's living, but the 4 to the -4 needs to come down to the denominator and change the sign on the exponent. And because we now left the numerator with nothing in it, we really left it with a 1, right? That's the 1 over. And now here, we can now use product rule, can't we? We have the same base. We're multiplying exponent powers of the same base. So product rule, I'm going to remind you that that tells you to keep the base and add the exponents. So please don't multiply those two bases. You keep the base, right? So you're going to write 1 over 4, and then we're going to add those two exponents. 2 plus 4 is 6. So we have 6 fourths in the denominator, and we're just going to write 1 over 4 to the 6. Our exponent is positive, so everything looks good. Okay, take a look at this problem. They're starting to get a little bit more complicated, but that's okay. What I want you to look for are those terms that have negative exponents, those variables that have negative exponents. And so we've got the w to the negative 4 and the y to the negative 9. Those are the two that have negative exponents. The rest of the variables and the coefficient of 8, those all have positive exponents. So we're going to keep the terms that have the positive exponents, we're going to keep those where they're at. Okay, so I'm just rewriting the terms that have the positive exponents. Leave them where they're at. Do not move them. But the other two terms, they're going to move to the opposite part of the fraction. And that's because we're using reciprocals, right? Because as you know, w to the negative 4 is the reciprocal, 1 over w4. And 1 over y to the negative 9 can be written as y to the positive 9, just like that, but over 1. Do you see that? So these are reciprocals, so we're going to put them in this guy. This w to the 4th then is going to come down here, and then this y to the 9th is going to come up here, and it's going to join the x to the 6th. And we're done because we have no like bases, so we cannot use any more rules on these. Number 8, I want you to see something. That 12 and that 5, those are coefficients. Go ahead and just multiply those the way you know how. So that will be 60, won't it? So we have 60, but then we have, look at what we've got. Let me write it in. We have y to the negative 10th times y to the 7th. Okay, those have the same base, don't they? And we're multiplying them together. So we could use product rule. There's a couple of ways to handle this problem. Okay, so add the exponents. Even though you have that negative exponent, you still add. So we have y to the negative 10 times y to the 7th. So you're going to add the negative 10 with the positive 7. Bring down the 60, keep the base, and then negative 10 plus 7 is negative 3. Okay, but you're not done because we want our final answer to be with positive exponents only, and we've got that exponent of negative 3 with this y. 60, he's okay. This is 60 to the first power. He's fine. So then this, we need this reciprocal, don't we? So we'll have 60 times 1 over y to the 3rd, which gives us 60 over y to the 3rd. Okay, in number 9, there's a couple of things happening here. Let's look at the parentheses first. Let's look at that parentheses first. Let's take care of that. Okay, so here's what we have. We have a to the negative 5th power times b to the 3rd. We have that first. And then this is our negative exponent that needs to move. So we're going to write 1 over a to the 5th times, and the b cubed, he's okay. So we have b cubed over a to the 5th. And this is being raised to the negative 3rd power. So awesome. So guess what? We have a negative exponent out here. We are going to use the reciprocal of the base, and then change the sign of the exponent to a positive exponent, right? So, but the base now is a fraction. Do you see that? So the reciprocal of this base is going to be a to the 5th. It's going to be a to the 5th over b cubed. Notice that I have reciprocal. Here's my reciprocal. You see that? And then we are going to change the sign to a positive 3. You see that? See what we did? We did the reciprocal of the base, and that takes care of the negative that's in that negative 3 and makes the exponent positive. And then we have power rule to get rid of the parentheses, right? And we're going to cube the a to the 5th, put it here, cube the a to the 5th, so that's a to the 15th, a to the 15th, and then we're going to cube the b cubed. So we're cubing the a to the 5th and we're cubing the b cubed, so b to the 9th. We could have handled this problem in many different ways using different rules, but to arrive at the same answer. So if you had a thought of taking care of these negative exponents in a different order, go ahead and do your work and see if you end up with the same answer I ended up with, which is a to the 15th over b to the 9th. And you could probably be right because there's more than one way to do this problem. Okay, I'm going to stop the video right here. There are more problems to be done. Go to the next video to see some more of these problems.